So next up, we have Dr. Saulo Zoca from University of Tennessee. He's an assistant professor and the state extension beef cattle specialist, and he's going to talk to us about strategies to identify new fertility.
Right? We're going to right here. Okay. It's working. Thanks for the introduction, Kai. First thing, if you guys want to contact me, have questions, anything related to this presentation or some other things, I have my contact information there, my cell phone, and my email. Feel free to text me if that's what you prefer to do. I'm more than happy to help you out whatever way I can. So for this presentation, what I have laid for us, I'm going to do a brief introduction about our concept of bull fertility, talk a little bit about our current methods to evaluate bull fertility, and then we'll dive in a little bit into the development of new fertility markers for bulls, and we'll wrap it up with some take-home message from this presentation. So I think we heard this over and over here that reproductive efficiency is one of the key components there for our beef cattle sustainability. And when I say sustainability, I don't mean only environmental sustainability, but sustainability of the business, passing it down, making sure we stay profitable, economical, all that is associated to sustainability, in my opinion. And then if you think about the bull fertility, that is also a key component there for us to have that reproductive efficiency to work there. So the impact when we don't have highly fertile bull there or a good fertile bull there, so meaning that we have a subfertile bull, in the economics of our operation is associated to us having less cows pregnant. But not only that, those cows that get pregnant, we will have a great proportion of them getting pregnant later on our breeding season. And we're talking about the importance of getting those cows pregnant early on our breeding season, which all that impacts our weaning weight, so decreasing weaning weights. So having that highly fertile bull help us avoid some of these issues. Some of the factors that can impact bull fertility will be associated to structural soundness, disease, injuries, the temperature, especially in the testes there, so thermal stress to the testes that can cause semen production issues and nutritional issues. And if you look at this list, we've talked a little bit about several of these issues already, right? So what is our current method to evaluate bull fertility, right? And I think you guys should have an answer on your head right now, or you could speak it up right now for me, because our current method is a BSE, right? And we heard it a few times already about that. So BSE not only is our current method, but it's the standard and probably only method we have to evaluate bull's fertility as of right now. And a BSE, I think Dr. Perry did a good job when he did his presentation. No bias, since Dr. Perry was my PhD advisor, I liked what he talked, right? So the BSE should be what we say complete BSE, right? So going through the systematics of that breeding sounds exam and checking out those boxes, all those pieces there, not only skipping to the last one, right? So physical soundness, that scrotal circumference, and that semen quality. With that said, this presentation, we are focusing on the semen quality side. And then on that semen quality for the bull tempo, for the breeding sounds exam, what we're talking about is having that motility. So for the BSE, minimum requirement will be 30%. If we're thinking about the AI industry, what they do, so when they collect that semen, it has to be at least 60% progressively motile, right? Because we know approximately 50% of that sperm died during that process of cryopreservation, so freezing and thawing. So we aim higher so we can be within that 30% standard there or above. And morphology is for me, it's probably one of the most important pieces in there. And that's why it's 70% regardless of what we're using that semen for. So it's a bull with natural service. If you're freezing for AI, we still want to use 70%. So what do we expect on those BSEs, right? And when I talk about BSC, I always tell my producers in Tennessee, think of it as an insurance policy, right? I think everybody here that owns a vehicle have insurance. It's something that you pay, you don't like paying. But if you get in a wreck, you're glad that you had it, right? But you wish you don't get in a wreck, that you just wasted that money, right? That's the way I think about my insurance, right? I hope I'm just wasting that money. I'll never need to use it. So if I do a BSE and I pay for it, I'm hoping all my bulls pass. But if a bull is not going to pass, I want to know, right? So I don't put those bulls with my cows, so I avoid that subfertile animal. When we look at averages, we are talking about 20% of bulls fail their BSE, right? And that will be associated to semen quality, it will be associated to physical problems, or a combination of both. So where did that average come from? Some of those studies. 3,700 bulls there on the first study, about 24% fail. And if you look there, I lumped together unsaturated, so that truly failing, and the deferred ones. Basically, the deferred one, he's not ready to be used right now for a breeding purpose, right? We need to retest that bull later. So if you need to use that bull right away, that bull is not going to work for you, right? So that's why I sometimes lump them together. So second study there, 2,900 bulls, 18%. Third one, 1,300 bulls there, beef and dairy bulls there, about 37% on that one. Yearly Holstein bulls, 36% failing there, and 57% because of physical problems. So doing a throw BSC is important. Otherwise, some of those bulls would have just gone, but they are not able to actually breed cows. And then lastly, that graph on the side there, that is data I collected from 2019 and 2023 from the bull test in Tennessee. So 350 bulls, and we have about an average of 24% of those bulls failing. What is the take home message here? Bulls fail. And we just want to be proactive in testing those bulls to make sure those bulls that are not ready to breed our cows don't get to breed our cows. So our recommendation on this is to test those bulls before each breeding season. And sometimes we talk, oh, you test it every year. Yeah, most producers have one breeding season a year, but we have producers that have fall and spring cattle. Guess what? If you're using the same bull before each one of those breeding seasons, you do need to retest that bull. Okay? So if we start diving into a little bit more into that semen quality, right? So this presentation is related to development fertility markers. So I think I like to start with compensable and uncompensable traits. Okay, and that is stay with me here. It sometimes it's a little complex, a little hard to follow, but I believe the way we're going to go through here, I think you guys will be everybody will be able to understand what I'm saying. So compensable. So first of all, let me lay out the graph here. So I think pictures tells a lot for us, right? So in this figure here, so as we move up on the figure or on the graph, means we have higher fertility until we reach that optimal fertility for the female population. As we move from left to right on this graph, we're increasing the amount of sperm we are putting on that insemination dose. So we'll have bulls that behave like this. As we keep increasing insemination dose, they keep increasing their fertility all the way till they reach the optimum female fertility. It's the optimum female fertility, so it cannot go above it, right? But if you pay attention, both A and B reach that optimal female fertility at two different time concentrations, right, or number of sperm inseminated. The level or how they increase it and that slope is associated to what we call compensable traits. Basically, as we increase the insemination dose, we can compensate for the fertility issues that semen has, up to a maximum there. Okay, that is an issue if we don't have enough semen. However, we did a study a couple years ago, and we look at 3 different insemination doses, 10 million, 20 million, and 40 million. And actually we have duplicate there of the 20 million where the only difference was the color of the straw. And you can look there, we have over 1,000 insemination, over 1,100 insemination there per dose. There's no difference. Why do we pick 10 to 40? That's a standard dose our industry uses. It varies somewhere between 10 and 40 million sperm per straw. Why do we use 220s? What if that variation is just random? And that's what we want to understand. And if we look closer, the numerical changes between the 220s, because there is no statistical difference, is almost identical, the difference we got from the 10 to the 40. So there is no difference there. Then we get into the next one, right? So we can have bulls that don't reach the maximum fertility of our female population. Yeah, as we increase the insemination dose, there is a little increase there, but they either plateau or they never reach that, even with substantial amount to unrealistic amount of semen in there. So that's what we call uncompensable traits. So that actually is associated to the ability of that sperm after fertilization to develop that embryo. It either is not, it's allowing more than one sperm to fertilize, and if you have 2 or more sperm fertilizing that egg, it's not going to be viable, right? Or it's just, it blocks it, but it doesn't develop. There's other issues there. We'll talk a little bit more about it in a minute. So as we keep going here, so let's think about this uncompensable. So that impacts maximal fertility of those bulls. In that same study, so we have almost 5,000 inseminations over 4 bulls, give or take 1,000 inseminations per bull there, we saw fertility differences. And we planned to not have it as we were designing this. We did not want to have both fertility differences, but we did. And so what, right? What do we do? So we went to the lab and did several analyses, but we could not identify why they were different with all the analysis we did. And I'm not going to show all the data for that. But again, that is one study. This is some data I collected over the past about 2 years, almost 16, 15 inseminations there, average 58%. I think everybody would be happy with about 58% first service pregnancy rates, right, on fixed time AI. But if we look there, each one of those bulls, and we look at the bottom bulls, 5 bulls, the top 5 bulls, they represent about the same number of inseminations, but there is a 10 percentage points difference in pregnancy rates. Which group of bulls do you want to use? The top one or the bottom one? I don't think anybody wants the bottom one, right? Unfortunately, they all pass quality control, they all pass all the analysis we know, and we can't figure out what is the difference. So that comes, okay, we need to develop new things that we can differentiate those bulls. What causes or what makes a high fertility bull a high fertility? So if we look into our insights into that bull fertility itself, actually what we're trying to do is identify those uncompensable traits, right? Because we're talking about the level of fertility. Because we saw that the industry took over that compensable pretty much, and we don't have an issue with that compensable anymore when we think about AI. And if you think about a natural service scenario, there's plenty of sperm there, right? So it's not really an issue right now. We're focused on that, right? So at first, we thought, okay, if the sperm is dead, it's bad. I don't think that's a hard concept. If it's live, it's good. A little later, we realized, okay, not necessarily all live sperms are actually good. There are some good and some bad that are alive. So when we think about our diagnostic ability right now, that's what we have, right? Those are the components of our breed-science exam. Those are pretty much the components of our semen quality on our AI industry, or the major one at least. If they motility, they have to have a minimum motility, we talk about it. They have to have a minimum morphology, we talk about it, and that's about it. So what we are trying to do on research is going a little further, and within that viable live that we consider right now fertile population, dissect which one actually are the most highly fertile sperm subpopulation within that what we consider population. So that's tricky, right? Because we need to think about fertility is actually multifactorial. It's not a single trait. I already talked about, right? Motility, morphology, we already talked about too. But it's multi-trait. There's a lot more. And it also depends on several events happening in an orderly fashion. So in a specific time point and timing-wise between the male and the female for the fertilization and a viable pregnancy to happen. What do I mean by multifactorial, right? It means that I have several factors there that plays around that fertility. Let's look a little bit closer. So imagine this cube, and right in the middle of this cube is the optimum fertility. Now we have all these things pulling around, trying to move it, different forces pulling it, and if we get away from that center, we are not on optimal fertility anymore. Does it mean fertile? No, but we are away from optimal fertility. I have A through H. Maybe it's A through Z, maybe it's 1,000 or 2,000. We don't know how many factors plays a role in there. What do we know? Morphology and motility. We know that we need a minimum of 70% normal sperm. If we are below that, we start pulling away from that middle. 30% progressively motile. If we are out of that, we start pulling away from that middle. Another one we don't use a lot as fertility marker right now, but we know it plays a role. The reason we don't, and I had that conversation with some of our AI companies and partners, they don't see an issue with our goals. That's why it's not a routine analysis. If they have an issue, they may go in and look at as, okay, is that because of this? So we need DNA to be intact, full DNA, right? So when that sperm delivers that DNA to the oocyte, we need that DNA to be intact in order for them to match with the oocyte so they can generate that embryo that will generate that pregnancy. If we start increasing that DNA damage or the percentage of sperm within that ejaculate with issues, we start having problems. So we're pulling away from that optimal fertility. We have other factors there that we know play a role in sperm fertility, such as acrosome integrity, the viability of the sperm capacitation, proteins that are around the sperm or inside the sperm, epigenetics, metabolites, microRNAs, production and resistance to reactive oxygen species. The issue, we don't know how much we need of each one of those traits. What is the threshold that we need to be above of that is not pulling away from the middle? We know if we have too much is bad, but we don't know what is that too much. So you get us to that, we need that ejaculate and that inseminate to have enough of all these traits that we know are important, and even those that we still don't know, but we're going to be developing soon, to need the sperm to have enough of those traits for that to be considered high fertility. What do I mean enough? I don't know either. So we still need to figure out what is that enough for several of those traits. Okay? We know we have a threshold for some, but not for all. So that's something we keep in mind when we're looking for and trying to develop new fertility markers. So some of the technology or techniques that we can use associated to the development of these new fertility markers, for example, we can use microscopy, or especially with fluorescence or immunocytochemistry, so antibodies or different probes to tag different portions and parts of the sperm. We look under a special scope and we start looking at, and with those technologies, we can look a couple hundred sperm there and count there. It's very time and labor intensive, but it's a little cheap because we are using the time, not really equipment and machine to develop those things. So it's a good way to start when we're developing this. Another technology that we can use is flow cytometry. However, flow cytometry is a lot more expensive technology, but we can do very similar things, but now we can use 5,000 to 10,000 cells. So it creates a very stronger accuracy to what we're measuring. So even when we start developing with a microscope, we really want to move it to something where we can look in a flow cytometer, where we can have more accuracy to our analysis. The downside is more expensive to run those analyses, not only the machine, but the whole process itself. And more recently, we have the omics, right? And multi-omics type of deal. What I'm talking about, omics, right? So that's when we start getting into genetics or genomics, so analysis of that DNA and the genes inside that DNA. Epigenetics or epigenomics, excuse me, we look at DNA methylation, histone acetylation, those type of stuff. Then we have transcriptomics, where we're looking for mRNAs, microRNAs, small non-coding RNAs. And proteomics, we're looking at proteins, metabolites or metabolomics, lipidomics, lipids, and other omics that we have or may develop soon with all the technology we have available. So, and we can put several of those together in what we call multi-omics. So if we go back here, there are several different methods we can use here. The key component when we're developing this is not only find something that is relevant for bull fertility, but something that we can adapt to our field veterinarians or producers to use on their bulls and actually test those bulls for fertility. To not be only a research tool, but also be a diagnostic tool for us in the field. So wrapping up here, there's a couple more slides. If we think about bull fertility there or fertility potential there, what do we want from those bulls? We want those bulls to be healthy. I don't think that's news for anybody. We want the bull with a sufficient scrotal circumference so they can produce enough sperm throughout the breeding season there. We want those bulls to produce a good ejaculate that has enough of all the desirable characteristics. Currently, motility and morphology, but hopefully we can come up with something newer that we can add on. We have to remember when we're talking about this that sperm population is heterogeneous. So we're not only male and female sperm, so the X and Y sperm, but also we have the good, the bad, and the one that is kind of in between there that we're still trying to figure out where the good and bad, the good and that somewhat in between separates. And focus on those sperm qualities associated to, that producing that viable embryo or that viable pregnancy. If you want to improve our prediction ability of fertility, we need to either develop new fertility markers or go back to some of those that I already mentioned and start validating them and find thresholds where we need to cut them off as minimum for the industry. As I mentioned before, when we develop those, they have to be easy to perform by either the AI industry or by our veterinarians in the field once we develop those. And we need to understand what is enough of those sperm characteristics. With that, I just want to say thank you. I don't have an acknowledgement slide here, but there are several people that helped me, and not only on this presentation by training. Joe Dalton is sitting here, wrote the proceedings with me. And we go in a lot more detail on the proceedings. If you guys want to know more about this, you can read the proceedings, but also contact me, and I'll be happy to take any questions that I think I would have a lot